Hey
Good
Tim, how you
evening,
doing?
everyone. I'm just fine now. You?
Doing all right. Here with my assistant Naz, who doesn't know that he enjoys live streaming. How are you doing, Tim?
I'm just fine. I'm just fine. I'm just wrapping up a new release, so that's always good. Just in time for the call here, so that's good. And, yeah.
Excellent. What do we got in this new release? Anything particularly good that people need to know
Uh,
about?
it is a wrap up of 3 weeks. Usually we do 2 weeks, but now it's a wrap up of 2 weeks, 3 weeks. So there's 186 items closed on the open source backlog. And I haven't yet been able to dive into exactly everything that's new. So, of course, new in there is some of the recipes towards Spring Boot 3.5 is in there. We've also
Mm-hmm.
tackled some long-standing issues for folks who are not able to get their dependencies resolved when they are using complicated Maven transitive dependency management versions with classifiers and types. So Thorsten, a member of our open source community, has been instrumental in getting it solved. So that's really good. And
Yeah, I
then
feel like I
yeah,
just yesterday merged a PR that had something to do with making sure that classifiers were taken into account in some aspect of Maven dependency management. So
yeah.
that sounds familiar.
Yeah, that's the both aspects of Maven dependency management and also for downloads. Those are being handled better right now. So that's really good
Mm,
because we've had a lot of long-standing complaints that were very hard to pin down, and now finally we have something to see that through.
yeah.
And I know on your end, you've also been working towards some issues that we saw recently with like performance, which we'll go into a bit more depth later on.
Yeah.
But I figured I'd for now take you all through the usual like couple of things that are new in the past couple of weeks. And for that, I'm going to share a quick screen. Because one of the things that new is that we now have the keynote address from the Code Remix Summit, which we had 2 weeks ago. That one is now online on YouTube. So if you're already watching us on YouTube right now here, then you should be able to click through to that one. I'll share a link in the chat here as well. But that one was really insightful to see how Morgan Stanley is using the recipes that we collectively all develop to upgrade very large size company there. So be sure to check it out. I really enjoyed that one. And then beyond that, you'll see these release notes show up pretty soon in the docs. Um, this is everything that's going to that has made it into the 8.45 54 release that we just did. And then I'll let you know when they're available in the docs, and I'll also post the details in the Slack channel that we have, and on Blue Sky, Twitter, all of those channels. So know that that's coming. And then looking ahead, like I just got back from Spring I/O in the past week, which was a ton of fun. But looking ahead, there's already a new conference on the horizon next Tuesday. I'll be presenting on the trusting AI to make changes at scale, which is a new presentation of mine. And then the next week after, I'll be giving the same presentation in Stockholm. So if you're near there, you have another chance to see it. And if that doesn't work for you, then in Luxembourg, you'll be able to see the same still. So looking forward to all three of those, and then hope to see you at one of them pretty soon. So that's it in terms of like the usual updates that we have.
How many talks do you have coming up on your schedule, Tim? Is it just that one, or do you have like another six planned after that?
So it's just these three. Like there's like a pre-summer season and a post-summer season. So I've not
Mm,
yet heard about any talks getting accepted after summer. So I'm just going to
gotcha.
enjoy, do some mountain biking and other things that I like to do when I'm not preparing talks over the weekend. So
Nice,
that should
nice,
be good.
nice.
No. And then at Spring I/O, I did a new talk, which was on better assertions with AssertJ, which was a ton
Oh
of
yeah, how
fun.
did that
So
go?
yeah, very good. Yeah, I'm hoping that the video is going to show up soon. There's already a couple of videos out there, but we'll share it as soon as we have it. But it
Nice.
was
What's
yeah,
the
a lot
what's
of
the
fun.
most impressive AssertJ assertion you've ever put together, where you were like testing like 12 things and had perfect like reasons for each of them and used some of the cool features?
There's a couple of neat things that you could be doing that I didn't know even preparing for this talk, which was where you can provide your own assertion provider, which you can then throw into like an assert that, and then have those familiar chained assertions that you could be doing. And the folks at Spring are also now taking advantage of that. We can give a very brief demo of that if you.
Yeah,
If you'd
I'm
like.
curious. I mean, while you were out, I was hyping up your AssertJ assertions talk, and I didn't get to attend myself, so I've been curious this whole time.
Yeah, sure. So this is one part of that presentation, and this is zooming into the new support that they have with the mock MVC tester, where if you want to do assertions on the way that your mock MVC controllers are handling requests and giving back responses, then in the old days you had to use Handcrest with a lot of individual static inputs, which
Right.
I have an opinion on. I could never like quite figure out which one of it was. Some of them are in different packages. It's quite annoying to have to compose your request while having to memorize each individual one, like a content, JSON, status, and so then this is how you used to do your request. Like you'd get a mock MVC, you'd do like a get request, and then you expect, and then you add various individual assertions here. But it is quite cumbersome. So what they added in the new version is that exact assertion provider that I told you. So now if you use the mock MVC tester, you'll notice that you only need a single static import for AssertJ. There's also one fewer to do your setup, which is also good. And then you can get the familiar assert that, pass in the request that you're performing, and then do all these fluent assertions in a way that your IDE is going to be very helpful in giving you additional content of what all is available to you.
And so these fluent assertions, this MVC test result assert, is something provided by the Spring framework. Is that right?
Yeah. So you compose a request, and that returns you a mock MVC test result, which implements the assert provider interface, and that then means that you can just pass that into the regular assert that. No, it's just the plain AssertJ assert that, and then get all of these helpful assertions. So this is something that we could even consider doing ourselves if we.
Yeah, I was going to ask. There's most of the assertions for recipe testing are kind of built into that rewrite run function. Although occasionally, if you want to make some additional assertion, you might use the spec parameter to do something with the LST that was the result of the recipe. Do you have ideas or thoughts about enhancements to our test framework? Like, is there an abstract assert class that we should be implementing, you think, or that would do something cool for any of our tests or our users' recipe tests?
I have explored it a bit. So so what we could be looking at is those specs that we have and have those be available for usage with AssertJ. But it's not ideal in the sense that how we use those now is sort of like a customizer. Another option that we could do is have rewrite run return that assert provider and then pass that into assert that. So you just have assert that, rewrite run all of these specs, and then build out fluent assertions there. But it's just for now, it's a cool idea. But I didn't want to have it like a use case where you think, well, I have this solution, now I need to find a problem that fits it. So
right. This is definitely. I'm like, wow, what a
the
cool solution. Do we have a corresponding problem?
So I'll keep my eyes out, but for now it's just knowing that this is available and then having a talk and a video that I can refer to for folks' usage. That is already neat for me personally. So,
Right on.
And then perhaps cool to say for the adoption from going to this older style to the newer style, there we don't yet have recipes, but there is a intermediate what we could add quite easily. So as we notice here that you'll have that mock MVC perform.get. So if you've put some effort into being able to write your own custom ways that you can do these requests, maybe add some headers that you need specifically, then it might be quite cumbersome to adopt a new style of building that up with the Modern VC tester. So they have a bridge, sort of, where you can use the old style that you had to do your requests. So this one is the same left and right, but then still pass that into that, assert that for the fluent assertions at least. So that's an intermediate that we could be looking at an easy target for recipes, and then gradually build out that complete migration from going from left to the complete new that you want to be looking at. So something cool to look towards, and this is just gonna be coming up with recipes in the near future.
Very cool.
So that's one part of what you could get with Spring Framework 6.2, as included with Spring Boot 3.5, which is available as of last Thursday, of course.
All right, yeah. Yeah, and we have a recipe to help out with the Spring Boot 5 migration, or at least kind of the beginnings of one. It isn't super comprehensive yet. Tim, do you know if we have specific plans to invest in adding a bunch of things to the Spring 3.5 recipe?
Yeah, absolutely. So we already we wanted to get a head start. So what we've been doing over the past month or so is that we looked at the release candidates that were available and the necessary changes within the going to Spring Boot 3.5, and that has led to the following set of recipes which we've already implemented. So there's this use bean name application task executor instead of task executor. That is a recipe that we already deduced as something that we could automate. There's a few of the regular associated changes that we needed to do, like upgrading your dependencies, unpinning your dependencies, upgrading your plugins, making sure that you're on a compatible Spring Cloud release. All of those types of changes we've already taken care of. That Spring Cloud release, I think, is coming out today or tomorrow, if I recall
Exciting.
correctly. So if you had already migrated, you might have run into some issues with Spring Cloud, so that should be clearing out pretty soon. And then beyond that, yeah, just we figured that there's not a lot of breaking changes necessary in this particular release. So you could be well positioned to upgrade, see how far you get, and then hopefully not have a lot of additional work to do. But of course, we'll be pulling in anything that we can think of for further changes just yet.
Yeah, and this is a proprietary recipe, isn't that correct? So this is part of the commercial IO Moderne recipe rewrite Spring, not the fully free and open source rewrite Spring. Isn't that correct, Tim?
Yeah, indeed. So these are recipes that we have developed at Moderne. And for now, we're offering these to our customers at Moderne. And that way they can help prove out these recipes, upgrade themselves already. And then we'll be working with the community in the time ahead to see if we can bring parity to the open source community recipes as well.
Now, is the plan to build a, you're kind of alluding towards like building up a separate but equal kind of open source recipe for it. Is that the plan, or are we maybe after some period of time going to be like, okay, as Spring 3.6 comes out, we'll move the Spring 3.5 recipe into the open source recipe module?
Well, we're still figuring out the details there. So indeed,
Yeah.
we want folks to feel supported. So we're gonna, if someone comes up with a community contribution, we're gonna review that, improve that, get it merged, and make it available, as we've been doing over the past half a year or multiple years actually.
Right.
And then from there, see where things go. Like we do understand that the support timelines of Spring Boot versions are speeding up considerably. So you now have to be on a version that is at most a year old. So maybe you can offer something for folks to get at least onto a supported version, and then keep the very latest version as something that you can get as a premium from using Moderne.
Yeah, and again, it's not that we so much wanted to charge people for recipes or anything. Originally we released all of this stuff Apache 2, figuring that if people come other people other than us commercialized it, that they would at least contribute recipes back. But that isn't what we
Yeah.
saw. That people were making competing products and maybe mentioning
Mm-hmm.
OpenRewrite once in a footnote of
Yeah.
the whole thing, and then never mentioning again that their cool AI
Yeah.
tool was actually just running an OpenRewrite recipe that we and our community contributors had been the ones to actually put together. So kind of regrettable, but I hope everyone will
Yeah.
understand why it has kind of ended up that way. Not looking to
Yeah.
nickel and dime anybody, but not looking to do all of the investment for someone else's business to reap all the rewards either.
Indeed, indeed. So any community member that contributes to these recipes is able to use the recipes that are just community owned. And then beyond that, of course, we as a bit of differentiation at Moderne, you're able to get onto those latest versions the moment they become available.
Wow. Yeah, good stuff. Yeah, anything else to say about the contents of this recipe? Yeah, or should we move on to
Um, yeah, so like I said, there's not been a lot of breaking changes, but it is quite interesting looking ahead. Like, of course, last week I was in Barcelona, and then you could see the changes that we're building up for in the Spring Boot 4.0 release and the Spring Framework 7 release. And those contain changes that you can already prepare yourself for right now. So that's going beyond what you would see for the Spring Boot 3.5 migration specifically. But with the themes for the next release, those are going to be to use Jakarta EE11. That's going to be, bring in JSpecify into the core of Spring Framework, such that you always know if it's something is nullable, not nullable, or maybe not defined. And then you can already run recipes yourself to maybe make sure that your own code is taking advantage of those nullable annotations for JSpecify. And then, of course, we have you covered there. So if you're interested in that type of like pre-work leading up to the fall, then you can already run the recipes that we have in that space.
nice?
We've used this on our own code. We've used it on our own recipes as well. So you should always have a clear idea of whether something you're getting back is nullable or not. And then we've used this also to switch away from the nullable annotations of the past. I know Merlin has given a nice talk in Cologne about JCon, about all the various ways when you had to specify whether your field is null or not. And now we have the next standard to help assert that it is all null or not. But this is broadly supported, this one, so you can support your migration to this one already.
Right on.
And similarly, if you're looking ahead at getting a head start on the 4.0 and 7.0 migration, that will also take better advantage of features from Java 24 and 25, where we already had virtual threads in earlier Java versions, like Java 21. But in 24, there is less issues with locking. So if you want to take full advantage of the improved performance that you get there, then we have a recipe to upgrade you to Java 25 already. So if that is of interest, we've recently added some additional recipes here to allow you to adopt these. And we have recipes still to allow you to discover where you could be using virtual threads, not yet adopt automatically virtual threads, but where they are currently used and could be used further. And we have some recipes to help you there. So all the links that I'm showing you, I'm also just putting in the chat, and then from there you can see whether any of that is of interest to you.
Very good. Very good. So, one thing that has been on my mind with this Spring Boot 3.5 migration has been recipe performance. As you saw when we had the visualization up on the screen, the Spring migration is what 3,500 individual steps now, which is quite a few things to chain together, and we were having some, but not all customers complain about it timing out. And yeah, it's a lot of steps, and they were running it on some large repositories. but just our intuition of how long these recipes should be taking, it still seemed quite excessive. So I thought I would share with all of you today some tips on how to investigate recipe performance, a few like pitfalls to avoid, as well as what we ultimately ended up doing to resolve those timeouts in the Spring 3.5 recipe. Um, so unfortunately, I don't have a chart from when it was timing out to show you. I don't know where I misplaced that, but I what I do have is the kind of like steps that you can start to take if you're having a performance question about your recipe, about any recipe that you're running. So I've run like the Spring Boot 3.5 migration here on some modestly sized repositories, kind of under 1,000 files, and on some of them it's reasonably quick. I think some of these times could still be brought down. This is after the change we made to improve performance, which let me see. Do I still have the chart from our metrics? Man, where did I post that? Sort of being a little disorganized about this. I'm kind of
Mm-hmm.
cobbling together this narrative from an investigation that was largely still in progress. But anyway, so like if you're running a recipe and you're wondering why it's slow, one of the first things that you should be aware of is that on any, particularly if it's a large composite recipe and you don't know which of dozens or thousands of steps is responsible, is that every recipe run could produce this recipe performance data table, which whether you're using the CLI or an open source plugin or the Moderne SaaS, which will as we'll open it up and see in a moment here, show you in detail where all of the time went. Let's pop this up in Excel, and we can see that for this recipe run, this has recorded all of these various columns as we're used to in a data table. First couple columns are just what repository it ran on, and then we get into seeing which of these recipes or which recipe from this larger composite is taking how many source files did it run on, how many source files did it suggest changes to, and then timings for the total amount of time spent scanning, the 99th percentile, so like how long the almost the longest one took on any individual source file it ran on, for scanning if it's a scanning recipe, and then edit time kind of regardless. And so you can go and do all of your usual Excel analysis, sort everything by this column or that column, but we also just have this Jupyter notebook, one of these visualizations for recipe performance that just goes and produces this visualization based on it. So this is based on the exact same data table that I just showed you. Just a little processing done to sort by the top 10 recipes by amount of time spent. And we see that in this particular one, we've got the time we're ending up spending is kind of dominated by some of these JUnit 5 recipes, and this is just like total time. So this chart does not on its own differentiate between like one recipe that takes 100 seconds and 100 copies of that recipe that each take 1 second. So
Mm-hmm.
it's not like the end all be all of like being at the top of this graph might mean that a recipe is popular within the larger composite, or it might mean that it's pathologically slow. So this is really the starting point for an analysis, not the end point. And we might well put together some additional visualizations like this one, like if this chart was divided, like if these bars were divided by how many instances of the recipe appeared in that larger composite, that could give you just a better sense for which recipes have a pathology to them and which are just have many copies. And then the before we made the fix, this time was actually dominated by upgrade dependency version, which is now taking there's probably still some improvements that could be made here to upgrade dependency version. Although this guy does a lot, particularly on the Gradle side. So how much more we can optimize it is kind of an open question. But this was twice as long as any of the other bars. And we realized, looking at some of our metrics on the back end, that the customers for whom this was timing out had really high latencies when their Artifactory was queried for Maven metadata, which Maven metadata is just a listing for any given Maven dependencies in a Maven repository, is just a listing of what versions are available, which within most usages of upgrade dependency version, it's not usually configured with a strict literal version number. It's not usually upgrade me to Spring Framework 5.3.3. It's usually like upgrade me to Spring Framework 5.3.x, which stands for a dynamic version lookup of the latest patch version under major version 5, minor version 3. And so this the dozens and dozens of copies of upgrade dependency version that are part of this recipe would be running potentially on many worker processes at once, all querying the Artifactory at once. And so if this is run in the middle of like a workday or something, that might already be under strain. And so it was just those metadata requests that were causing the recipe to time out. Which is to say, it the recipe was hitting like the 9-minute timeout we were getting, and as soon as we increased the expiration time on the Maven metadata cache, which already exists. If you're familiar, if you've gone into OpenRewrite internals and looked at the dependency manipulating recipes, you would see that there is a cache for some of that stuff that has a certain expiration time on it. And so by increasing that expiration time, it went from timing out at 9 minutes to completing in only 30 seconds, which is much better. But there's still improvements to be made here into recipes in general. So I thought one thing I would share is a way to take this even a step further. Because let's see here, I just ran the regular Migrate to Spring Boot 3.5 on this collection of repositories. If you look at the recipe run times here, the slowest one takes like 4 minutes, and we've got some in the middle taking more like a minute and a half. And I'll just go ahead and kick this off so it can be running while we kind of talk about it. But here is another version of the Spring 3.5 recipe, where all I have changed is to add in some scanning preconditions. Now, scanning preconditions are a new feature that I added to the framework not super long ago, maybe a month or something like that. So we haven't really talked about them much on Code Remix yet. So I think this is a good opportunity to mention them. But so, I added this recipe called repository has dependency, which all it does, if you were to look at the implementation of this recipe, which I suppose we could do real quick because it's not very complicated. It's just over in rewrite Java dependencies. We go look at, probably even have it open. Yeah, so you'll look at repository has dependency. It's a pretty typical scanning recipe, which it's a pretty typical scanning recipe in most respects. Excuse me. But it has a few attributes that make it suitable to be used as a precondition in a YAML recipe. So first off, this is just going to look through, it's going to use the dependency insight recipe to just check any relevant file it comes across to be like, hey, do you have a direct or transitive dependency on this thing we're searching for? And if so, just set the accumulator to true. And if that accumulator has been set to true, from the scanning phase, in the visit phase, uh, if it's true, just marks everything in the entire repository as a search result. And if it's false, mark nothing as a search result. And so what this lets you do is, if you use it as a precondition in a YAML recipe, we can make it so that all the other recipes under Migrate to Spring Boot 3.2, all of these only run if the org.spring framework with the version between 1 and 6.1 have been found somewhere in the repository. And I've added a few steps like this to the YAML recipe builder, kind of at some of the breakpoints where some of these dependency versions have made changes, right? Like Spring Boot, 2.7.3.3.1 kind of had some of the same versions, used the same version of Spring Framework under the hood, so I didn't do separate preconditions for those. But let's see, if we kept digging into these, and we'd find another one or two I add. So this is, fairly kind of coarse-grained sort of optimization. The basic logic being like, hey, if you're already on, Spring Boot 3, you don't necessarily need to run all of the recipes involved in migrating from earlier Spring Boot versions. Now, put an asterisk in that, put a pin in that for the moment. But anyway, let's go take a look at how this is running performance-wise, and see see if this has made much of a difference. Looks like some of these are still running, but maybe we can go ahead and compare some of them to the recipe run without these preconditions. So like here's Symphony WDK, which in our previous run took just under 5 minutes. And Symphony WDK, okay, that one's still running. Maybe let's look at Symphony BDK Java. Did that make any difference? Symphony BDK Java finished in 1:17, and here it took basically the exact same amount of time. So yeah, as you could, with
AWS SaaS Boost. If you look at that one, that now in the modified recipe takes 35 seconds. Let's round it up, and that used to take 3 times as long.
Yeah, a minute and 30 seconds. Yeah, so as you can see, with this kind of like coarse-grained application of preconditions, whether there's any benefit or not, very much depends upon what version of Spring Framework you were on. If you were on a version, earlier than wherever I put like the latest precondition, then obviously you would get no benefit at all. And indeed, there's some amount of overhead to including the preconditions. But if you were on, on one of these higher versions, then you would be saved from running these potentially unnecessary lower steps. So yeah, some performance benefit to be had by doing this, but I haven't fully checked this in, partially because increasing the caching side, or the cache expiration time, resolves the worst of the performance problem, and partially because there are some downsides to doing this. Right, there are some steps that like you don't have to upgrade from JUnit 4 to 5 as early as we have the JUnit 4 to 5 upgrade recipe in here. So it's not uncommon that you could have like a Spring Boot 3 project that was still on an older version of JUnit and could benefit from being uplifted to JUnit 3.5. So that's part of why I haven't checked these in. We might try to do something finer grained, particularly since we kind of know from this chart which recipes are, or the chart that I had, wherever it went, we know which recipes are kind of expensive, that maybe we would just group those together and only apply preconditions to those, like for the dependency upgrades, right? Because like if you're migrating to Spring Boot 3.5, there's still all of the like old upgrade Maven or Gradle dependency versions, recipes included in the older parts of those recipe. That's kind of redundant. You have this big tree full with a bunch of upgrade dependency versions in it for the same, Spring Framework boot dependency. You only really need whichever the newest one of those is, So, one reason I've kind of hesitated to do that is every time we like decompose these recipes into sub recipes with their own preconditions, it bloats the recipe catalog, right? It's now we would, instead of having just like migrate to Spring Boot 2.1, we'd have migrate to Spring Boot 2.1 overall, migrate to Spring Boot 2.1 dependencies only, so I could put a precondition on those, migrate to Spring Boot 2.1 no dependencies, so that wouldn't have to have a precondition. And so I've kind of been toying with the idea of, in the YAML, maybe introducing some notion of like an anonymous recipe, something where you could make, like, within a recipe list, you could group some recipes together with their own preconditions, and then, but it wouldn't show up with its own name in the recipe catalog. So it wouldn't be something you'd ever want to run on its own, divorced from its larger context. So that's just an idea for now, not something we've actually implemented. But you think it would sound cool, or you think that's stupid, let me know in the community Slack, and we can talk about it. Yeah, so let's see. So that's kind of the current story with performance. Oh, hey, we got this recipe run done. Yeah, so we see that for some of these it made a big difference, like Symphony WDK, about the same amount of time on both. Well, not entirely, 4 minutes 20 seconds down from 4 minutes 50 seconds. This let's see, we got message ML utils. Yeah, really dramatic difference on this guy. This one dropped down to just 10 seconds from 4 minutes. Now, of course, this also prevented most of the changes. So this did prevent some changes from being made to it, right? Like previously, this was having a number of changes applied to it, which that precondition prevented. Yeah, so stuff from the 11 to 17 migration didn't get done. So you kind of see some of why I haven't rushed to coarsely apply this precondition strategy everywhere, as it is the kind of optimization which could undercut the correct behavior of the recipe if you were indelicate with it. But even though this hasn't, these preconditions haven't been checked into this recipe, if you are working on a recipe that you want to have a precondition like this, know that that's available, and know that you can now use these in a YAML recipe to say only run this recipe on modules, on sub-projects where a particular dependency or build plugin is present. That's something we've had requested for a while. Or you can do something repository level, or if you have some other scope that's relevant that you could define as a recipe, you could do that there as well. Okay, so yeah, so that's kind of the story with that. But kind of as part of this performance investigation, as part of this performance investigation, we or I looked at a couple other recipes that show up prominently in where the time is going. One of them is change type. This is a very common utility recipe that shows up a lot in various upgrade recipes, and I haven't fixed it yet, but I did investigate kind of why it's taking so long. And I think it'll be instructive to kind of take a look at what's going on in change type, so you can keep an eye out in your own recipes for this kind of inefficiency. So looking at change type, one of the first things I kind of noticed was that it uses preconditions, right? This is in the get visitor method of change type. It uses a precondition, and one thing it does is it checks to see if the or if the file being visited declares a class that it has been instructed to rename, to change from one thing to another. But this contains class definition check involves I haven't actually checked in this change yet. This is one thing I was considering. This involves doing, essentially a full traversal of the entire tree to just look to find all of the class definitions or all of the class declarations and check to see if they are the class declaration of interest, which is to say you're doing one full traversal, one loop through all of the LST elements in every single tree, even ones that would not otherwise, that don't have the type being renamed and don't have the class definition of that one type. So, I'm looking into ways to make this particular check cheaper, so that we're not spending a lot of time just evaluating the precondition that says, hey, this doesn't need to run on this file. It has no changes to make. So keeping your visitors preconditions cheap is a big part of good performance. And then another part of it is that in the implementation of this recipe, when there are some changes to be made, there are not just one full traversal of the tree, but two full traversals of the tree. If we look inside of this Java change type visitor, it both it has one traversal in this visitor, and then it has another full traversal in this sub visitor change class definition, which is again kind of related to just changing, updating the class definition for the type being specified, which in most usages of change type isn't a concern at all. The way this is mostly used is to rename types from a library, not to rename the definition of the type itself. So this is kind of a slightly uncommon edge case, which is costing two full traversals of the tree out of three full traversals of the tree. So with some refactoring, this recipe could potentially take about a third of the time that it's taking now. And we obviously haven't done that refactoring yet, but that is kind of the analysis here. Oh yeah, and I also helped a customer. One kind of final performance story while we're on the subject is a customer had written a recipe that was timing out, and let's see, I think I have the source code for it still, but let me make sure that there's nothing sensitive or private or identifying of this particular customer before I post it. Yeah, okay, so I have the text here. I maybe need to quickly take out a few names so that it doesn't look, because I'm not trying to put anybody on blast, Let's see. I'll say.
The always tricky topic of reducing a problem to just the non-identifying elements that you need to reproduce the issue. We see that too often. Yeah.
It's quite it's a fairly generic sort of recipe that I think will be pretty easy for people to understand. It's just a matter of changing a name or two, but I think I have taken out anything that would be too significant. So this is the recipe, right? It's not a scanning recipe. It's just a basic, update, a recipe that goes and replaces a variable declaration that has a particular annotation with an initializing. And the basic idea here was there's like a logging framework that you used to have an annotation over your logger to do some initialization. And they're like, let's remove the annotation and just put the initialization, the correct initializing expression there. Then we can get rid of this annotation processor that we used. And so pretty typical guy. It's got a precondition. It uses type, so they're already only going to apply this recipe when this type is there. There's an unnecessary wrapping of this in preconditions.or, which is only necessary if you are going to kind of group multiple preconditions together into a single one. But the amount of additional overhead from this is a couple function calls. Nothing particularly significant, so that's not the performance problem. Then inside of the actual implementation of the visitor, they are putting a template declaration onto a field of the visitor class, and then they get into changing the annotation itself. They go visit all the variable declarations. They go strip out the variable or the annotation they're looking for, and they check and see, hey, did anything get stripped out by that? And this shows an understanding of how listutils.map and how the LST types work, because listutils.map, if it doesn't make any changes to the underlying list, it just gives you that list back. unlike doing like stream and collect, or iterating through and copying to a new array, this will not instantiate a new list unless there's something new to instantiate. So they're able to use this referential equality check to tell if anything was removed in this listutils.map call or not. And so they return early, and then excuse me, some type information is missing. They add some warnings about that, and then finally when you've satisfied all the defensive criteria and found that they are looking at the thing they want to change, they apply the template and do the import manipulation. And this recipe, which is pretty straightforward and pretty simple and very similar to a lot of other recipes, was timing out on modestly sized projects. And so, take a second to think about it if you see what the performance problem in here is. Because when I first looked at it, I saw a couple things that I thought were a little funky, like this preconditions.or that was unnecessary. Nothing that jumped out to me as the performance problem. But ultimately, the performance problem is just this. It's just instantiating this template on a class field. And one hint that this is a wrong thing to do was that they instantiated a new execution context here rather than using, as you always should, using the execution context that's passed in to the visitor. And this is a bad thing to do for a number of reasons, right? Like the reason that the execution context is a parameter to this class path from resources function is that this does a little bit of file IO, right? This writes out some temporary files to disk, and it uses information in the execution context to know where that is. So if that location had been customized from the default location, this would ignore that configuration and write things out to the default location anyway, which in some contexts might not be writable or accessible to it. So that's kind of a hint that this is the problem. But the real issue is that this class path from resources call takes, it invokes class graph under the hood to scan the runtime class path to look for relevant stuff, to feed this template the information it needs, and that takes about 150 milliseconds, at least on my machine, which is to say but that's not so bad, but it's actually per source, even when this precondition isn't going to evaluate to true, because this is, initializing a field on a class happens when that class's constructor is called. It happens when new Java ISO visitor is called. Like if you were to look at the bytecode for a class that has initializers on its fields, you'll see that the bytecode for this expression is moved into the constructor call, right? So this is not anything that's lazily evaluated at all. And actually, the rest of this stuff is actually, totally irrelevant from a performance standpoint. Just like if I reduce this recipe to just this, to take out the precondition, whether the precondition is there or not doesn't actually matter in this case. If I reduce this recipe down to just this, it still takes about the same amount of time, because this 150 millisecond call to class path from resources is made on every single source file, right? Even if this, maybe I should put the precondition back, but yeah, this 150 millisecond call is made in every single source file, because this isn't the second argument to preconditions that check isn't a provider of visitor. It is just a visitor. Maybe it should be a provider or visitor. I don't know. We wouldn't have this problem if this was if the API looked like this. But it is what it is currently. Maybe we should change it. Maybe not. But for now, I'm just as a tip to all the recipe authors out there, never instantiate your own execution context, because we are losing the actual execution context, which might really matter for something, right? Like another thing, like if you instantiate your own execution context in a recipe that does HTTP communication, then it won't respect the proxy settings or any of the other things that might be absolutely critical to the HTTP communication being able to succeed in a variety of environments. So never instantiate your own execution context, and be wary of putting anything expensive into the initializer on a class field, because that's going to run regardless of if that field is ever touched by anything. And that's just good performance advice for writing code in general. Just be be conscientious of those costs. So changing just this one thing took like if I as an example, just to investigate this, I took a recipe. I took basically this recipe with all the actual logic stripped out, and I ran it on the OpenRewrite repository, which has 2,600 source files in it. And it took 5 minutes. 5 minutes just to instantiate this object and scan the runtime class path 2,600 times. So honestly, it's still kind of on my list to go into class path from resources and make sure that it only actually has to do that scan once, so that if you did do successive calls, it wouldn't be such a problem. But the place it would end up cached if I did do that would be probably in the execution context. So if you were instantiating your own execution context, it would not help. So anyway, there's just a little recipe authoring performance mind to avoid stepping on. And yeah, let's see. I think that's basically all I have to say, or all of my findings from this recent foray into recipe performance.
And
Yeah,
and I think you also put some effort into it. We've not merged it yet, but some effort into using the testing framework that we have to validate that folks don't include this food gun in their recipes in their
that's
implementation.
right. That's right. Yeah, I did. I do have a branch open. Well, I should probably check back on that PR, see if I got any comments on it about changing in-memory execution context to throw an exception or to have an assertion in its constructor that would complain if it was run during after recipe, like if it was instantiated after recipe
Mm.
execution had started, at least in the context of doing tests. Is a little hacky, so I'm not, it's a little, I mean, like
Yeah,
it's a little janky. It's not like super thread safe. I mean, recipe execution is single threaded, so it's not like a huge deal. But like, it's a little bit of a hack. So I'm not sure if I'm going to get a bunch of pushback on that, or indeed if it's like it might mess things up a little bit, right? To do this. So
yeah,
I'll check with the team. I'll see what Knut thinks, see what Jonathan thinks. Like if it's worth going through it for this. Um, but yeah, don't instantiate your own execution context. It's not the context of the execution if you're making it up on the spot, right? Like it's
mm,
there in the name. Anyhow, yeah. So those are my tips for recipe performance. Be mindful of your class field initializers. Look at the data table and the charts, or the data table and the top 10 performance visualization. Know what it's telling you about whether or not it's one long recipe or 100 copies of a short recipe. Be aware that you can use those repository level preconditions or the scanning preconditions to narrow the scope of applicable parts of your recipes. And yeah, and if you have a slow artifactory, be sure you have the necessary. Well, I mean that's something that we just kind of handle. Um, use caches for accessing external resources for consistent performance characteristics.
yeah. Yeah,
Let's see.
it's been a really interesting week trying to hunt down the cause of these various performance issues, and really satisfying then to see things go from like timing out at more than 9 minutes to finishing in under half a minute. I mean,
Yeah,
this goes to shows where we're never quite satisfied, even if you're already saving you a couple of months worth of work, that we should be doing so in half a minute instead of 10.
totally, totally. Yeah, and I think it shows some of the wisdom of setting a timeout. Because like the 10-minute timeout is inconvenient when you hit it, but like if you don't have a limit somewhere where you're like, okay, we need to stop and investigate and actually fix the underlying performance problem. Like, how bad
Yeah,
do you let it get? Like, do you
yeah.
like is it's saving us months of work? Like, is it fine if it takes half an hour to run this recipe? Is it fine if it takes an hour to run the recipe? Some of the design considerations that went into the system make various assumptions, like about running a recipe being pretty fast. And so those assumptions would start to break, and other parts of the design would have to be questioned. So the timeout is kind of not it's the last line of defense, but it's an important line of defense
Oh.
against the design of the system breaking.
I think we have a similar design decision with the CLI, where we,
Yeah.
for reasons, only had a limit of 500 megabytes of what it should be fitting into, and then when you start to hit that limit, you start to rethink your design. I don't know, you somehow always end up close to the limits that you set.
Yeah, it's there's got to be some kind of truism. I'm sure some wise software engineer whose quote I'm not calling to mind, possibly just a wise process engineer in general from another field. There's no way this is exclusively true to software engineering. Has some very pithy thing to say about how limits help you out.
Yeah.
But I don't know that
So,
cool quote. Think of a cool quote that we could attribute to Tim Tobik for next time about the importance of timeouts or setting limits.
yeah. I'll try to come up with something smart, which might
You,
take a
you
while.
you go to a lot of talks. I think it's important that we have a nice, for you, that you have a nice photo of you looking off into the distance with a thoughtful, serious expression on your face. Then underneath it, we could put a really wise quote. Then all the many people who you see at conferences can be like, oh yeah, this Tim guy, he knows what he's talking about. He's wise. Look at how he's staring off into that sunset. He knows his stuff. He's a philosopher.
Yeah. At least at some point in his life, he uttered like 5 words that made sense. And, yeah,
Yeah, yeah, and,
yeah,
and and who can ask for more than that, really?
uh, so yeah.
Uh, All right, Tim. It's been fun. Any final remarks for today's stream?
No, not really. So like next week we're gonna have a very interesting topic, just something completely different. We're gonna bring
Yeah,
on Andrew Stockholm, and we're gonna talk about our support for C Sharp and .NET and how that will unlock the next bit of work that we can help folks automate and improve.
yeah. I think we'll be taking a little bit of a look under the hood at the Roslyn compiler and some of the cool functionality it has and features it provides and how we could bring some of that goodness into OpenRewrite. So yeah, I look forward to that. Um, and
Absolutely.
I don't know. I'm so used to like shilling for the Code Remix Summit. I feel like I need to tell people to go to the code to register and show up. We're surely going to have one in
Uh,
2026, but there's nothing to register for yet. But be ready.
so So what you can do is subscribe to our YouTube channel because we will
There you
be
go.
putting out more of the videos of what was recorded while we were there, and then
Excellent.
you'll be able to relive or see the things that you missed out on.
Yeah, yeah. There were some
Hope to
there
see
were
you
some
next
good
week.
talks. There were some good talks. It doesn't Dove's was great, but there's other good ones that are going to be posted over the coming days too. So yeah, keep an eye out for that, and hope you all enjoy.
Absolutely. Yeah. So thanks all for joining us, and we hope to see you next week.
Yeah, see you next week, everybody.